Today what I want you to do is label your notebooks with the intro to logs. And the first thing I want you to do is pause the video and see, what do you wonder about these? You don't necessarily have to write this in your notebook, but can you figure out what these are saying? So pause the video and take a minute or two to see if you can figure out what patterns they are. So hopefully some of you guys noticed that here's a pattern here. 2 to the third equals 8. 2 to the fifth equals 32. 3 squared equals 9. 3 to the fourth equals 81. And 5 squared equals 25. So we could try and evaluate these. 2 to some number here equals 16. Well, so that has to be 4. 6 to what power gives us 36? Well, that would be 2. This would be 5 to the third, gives us 125. 2 to the negative 1, so that's 1 over 2 to the first, so 1/2. 10 to something gives us 1 over 1,000. Well, that would have to be a negative exponent. 10 cubed gives us 1,000, so that would be a negative 3. Something squared gives us negative 1, so that's 9. Something to the fourth power gives us 81, so that would be 3. And something, 16 to the 3 over 2 gives us that number. Well, this is the square root of 16 cubed, so 4 cubed, which is 64. So what this pattern here is what a log is. A log is a different way of writing an exponent. So whereas up here we had a power, a log, short for logarithm, if I had said log base b of x equals a, converting that to exponential form, that's b to the a equals x. So always remember that our bases, the base of the log is the same as the base of an exponent. In a log, kind of like a tree, a log cuts down that exponent. So let's say we were to convert some of these. So let's say I had log base 3 of 8 equals x. If I was to convert that, that would be 3 to the x equals 8. If I had log base x minus 2 of 5 equals 11, my base of x minus 2 to the 11th equals 5. Now we can go the other way as well. If I had 3 to the x equals 14. If I was to go the other way, that would be log, our base is 3, of 14 equals x. Do you see what I mean? How it solves for the exponent? So our exponent is here, and it solves for it on one side. And then once again, our base stays our base. Then we could also say, let's say I had 4 to the x equals 13. So going the other way, that would be log base 4 of 13 equals x. Now, there's also something called the common log. And the common log, it just means that it has base 10. Kind of like when we write square roots, we don't have that 2 outside. Common log is base 10. It's used a lot, so we don't write that 10. So if you saw this, log base 18, that is the same as log base 10 of 18. So that base is that tiny subscript number. So if I just said log x, that is log base 10 of x.